Okay, welcome to Python programming language. In this lectures, we're going to discuss about list. This is Unit 7 lectures. Again, the concept of list is the same as array in Java programming language or C++. So let's say our opening problem. So let's say, for example, we have to read 100 numbers. Then we compute the average and find out how many numbers are above the average. So in order to solve this problem, it means we need to declare 100 variables. So we need 100 items. So this is where a list will come in. So in terms of a list, we can only declare one list and make the size 100. We can have all the items, all the 100 items in the list, one list. So again, it's the same as array. In Java, we use array, which means array consists of any amount of elements. The data type must be the same. So in this case, I have 100 decimal values or 100 whole numbers, integer. All the numbers have to be same data type. So again, the problem with this program is that we don't want to declare 100 variables. So the best way to solve this problem is to declare one array or a list. The size is 100. Then we can solve this problem more quicker. So let's see the objective. In these lectures, we're going to describe why lists are very useful in programming. Again, it's the same concept of as array. Also, how do we create a list in Python? And how do we invoke list append, insert, extend, remove, pop, index, count, sort, reverse method. This is one of the advantage of using lists in Python. List is a class, so it comes with a lot of methods. So append means if I have two lists, I can join them together. Or I can insert an item to a list if I already have the list. I can remove an item from a list. I can also pop, etc. And also we shall go through all these methods. Also, we are going to learn how to use the len, min, and mass. A len will give us the number of items in the list. Min will give us the minimum value in the list, and mass will give us the maximum value in the list. Now, if we have a list of items, we can use the sum function, sum to sum everything in the list. Also, we can shuffle our items in the list, which means we change the position of the items. Also, we're going to learn how to access list elements using the index variables. The index variables tell us the positions of the items or the elements. So an example, if I have a list and the size is 100, the index will start from 0 to 99. The first item will be index 0. The last item will be the index 99. So first we shall go through how to create a list. Now creating lists using the list class, as we said earlier in Python, list is a class. Even in Java also, we have array as a class also. So for example, we are creating our first list. And this will be an empty list because the name is list one, but we have lists with nothing in the parentheses. So this creates an empty list. Again, we know Python, the hash sign or the pound sign means comment. So next we create list two. We can create a list and specify the number of items inside. So here we have 3 elements, which are 2, 3, and 4. One thing we should know in the list is that all the elements in the list must be the same data type. And the next we have list 3. All the items are strings. We have red, green, and blue. We can also create a list using the range function. Require remember we use this range function in a loop, for loop. So if we say the range is from 3 to 6, it means we have 3, 4, and 5. Same as we use it in a for loop in our previous lectures. So we are creating a list. The item will be 3, 4, 5, and we are using the range function. The last list we create is called the list 5, and this list have items A, B, C, D, which means we are going to create a list and the item will be A, B, C. Now, for convenience, you may create a list using the following syntax. So instead of having the square bracket and the parentheses with a square bracket, we can just remove the parentheses. So if I'm creating an empty list, I'll just write list 1 with empty square bracket. List 2, square bracket 2, 3, 4, which means I have the same as using the parentheses also. List 3, we were using the parentheses before, we can remove it and become red and gray. Now, the next is the list method. As we said earlier in the objective, we have so many methods that we can use. Since list is a class, it has a lot of methods that we can use to manipulate or evaluate some data in the list. So for example, the first method is append. Append means we are going to add an items at the end of the list. So add an item X to the end of the list. It doesn't, none here means it doesn't expect a returning value. Same thing, we have an insert. Insert method, it takes argument index. The index always will be int because index will be the location of the items and normally start from 0 to 1 less than the size. So if the size is 10, from 0 to 9. If the size is 50, then we go from 0 to 49. So it takes 2 arguments, and also we have none here, which means the insert method doesn't expect a returning value. So we are going to insert an object in the position of the index that we specified. So the insert method will insert an item X at a given index. Here we should know that the first element in the list always starts from 0. Next, we can also use the remove method. Also, the method remove doesn't expect no returning value, so it's none. So this method, again, will remove the first occurrences of the item S of the list. So for example, if I say remove 2, anytime we come across the first 2 in the list, it will remove it. Again, list can have a duplicate of item. I can have, for example, a list of 2, 4, 2, 2, which means I have 2 3s or 3 2s. So only the first X value. So if it has 2 X value in the list, only the first one is going to remove. Also, if we want to know the index, that's the position of an item, we can use the method index. Index is expecting a returning value of int, the data type, because indexes are always a whole number, a data type. So this will return the index of an item X in the list. The index is the position where the item X is. Then also we have a method called count. This will return the number of times an item appears in the list. So if I say count S, if S appears only once, then it will return 1. If it twice, it will return 2. Now we have a special method called len, L-E-N. That returns the number of items we have in the list. So a count only will count the item you put in the argument here. Let's say X. If S is 2 and we have a list of values, it's always going to count how many 2s we have. But if we want to count all the items in the list, then we need to use the len, L-E-N method. We also use the sort. The sort method will sort all the items in the list. Also, if we want to reverse, we can use the reverse method to reverse our item in the list. Also, if we want to extend the item, the list, this will append all the items in the list in the L to the list. So for example, if I want to extend twice or three times, again depends, it will extend it for us. Also the last is to pop. Pop means to remove also. By it to remove the item at a given position. Remember, we use the method remove X. So when S, we see S the first time, if we have two or three S, the first S, we are going to remove only one. But with the pop, we can specify the item we want to remove. So pop here will remove an item at a given position and return it. So if I have three twos, one is in position 2, one is in position 5. If I specify that I want to remove the position 5 one, then it's good to use pop. Because if I use remove, I have to remove the position 2 first before the position 5, which means I have to call remove method twice. So let's see some examples. At least we went through some of the methods using in a list. Again, a list is a class. So when we create a list, it's like we create an object. And since we know class always consists of two things, the characteristics and the methods. So those are all the methods of, again, a list object if we create. They can use it then. So the first thing we have here, we create a list object called list1, and it has 5 values, 2, 3, 4, 1, 32. Now, if I call the method len with the argument of the list name, it will tell us how many items in the list. So it's going to return 5. And same thing if I call the method mass with the argument of the list name, it's going to return the maximum value in the list. So in this case, it will return 32. Now, if I use the min with the argument of the list name list1, it's going to return the minimum value, which in this case is 1. Now, if I call the sum method, the argument of the list name list1 is going to add all the items. So in this case, it's 42. We can see that 2 plus 3 is 5, 5 plus 4 is 9, 9 plus 1 is 10, 10 plus 32 is 42. So it returns the addition of all the elements. Now we can also import a random. We use this random class many times. If, for example, I want the program to randomly assign values, I can use random, or in this case, we are using it for shuffle. Shuffle also is a method in the random class. So in order to use the shuffle method, I need to import the random class. So we have import random class, then random.shuffle the list1, which means the list1 have 5 items here. We are going to change the position. When we shuffle it now, number 4 is the first. And this is randomly shuffled, so we don't specify the position. So 32 was last, now 32 is 4th position. So this is the indexer operator, that is the square bracket. So as we said, list is almost having the same syntax as array. Array uses a square bracket. As we said, the indexer will start from 0, and the maximum will be 1 less than the size of the array, or in this case, the list. So the item we have here is 10. We can see that the list starts from the index starts from 0 to 9, which is 10 items. So this will be called the list element at index 5, which is the 6th position. And the first position will be list 0. Index is 0. Now we can do some operations on the list. For example, plus. Plus will join 2 or more lists together. Normally we use it between 2 lists, so it will join the 2 together. Multiplication can make a copies of a list of items we have. Depends what value we are multiplying. And also we have the operator called the in operator also. So we are going to use the plus multiplication, square bracket with column, and also the in operators in a list. So here we start first that we have 2 lists. One is called list 1, the other is list 2. Both have 2 items, 2, 3, and 1, 9. Now, if I use the addition, it's not going to add the elements, but rather it's going to join the two lists together. So we had list 1 plus list 2, and we assign to list 3. We can see that list 3 now becomes the list of all the items in both lists. So it's more or less joining. List 1 is 2, 3, list 2 is 1, 9. So when we say list 1 plus list 2, it means we are joining 2 and 3 and 1, 9 all together, not adding them. Now the same thing applies if we say 2 times list 1. It doesn't mean that we are multiplying 2 by all the items in list 1. No. But rather, we are repeating it again. So the first 2 items, we know list, again, this is list 1. It has 2 and 3. So you can see that we repeat it twice more. So 2 and 3 comes again, 2 and 3 and 2 and 3. Same thing if you have 3 times, then 2 and 3, 2 and 3, another 2 and 3. So it will be 3 times. With the first one, initial one there. So there's no multiplication here. Now the next we have list 3. Remember list 3 here we have 6 items. Now we say list 3, 2 to 4. Which means, remember the index always start from 0. So the index 2 to 4, but it will go again 1 less. So when we look at the list 3, we have 2, 3, 2, 3, 2, 3, which is 0, 1, 2, 3, 4, and 5. 6 items, so from 0 to 5. The first index here is 2, so which means 0, 1, 2, we get our 2. And 4 means we go up to 3. It's the same thing applied to follow. When we put a range of items, the last items is not the position, it's 1 less. So this 4 means we go to index 2 and 3. Now we also have a list 1. This time we have 6 items. Now if we said list -1, it will give us the last item, which in this case is 21. Now when we say list -3, it will give us the 2, which is in the index 3. Now here also we have list 1 with the same items again. Now if we say 2 in list 1, so here we are using the in operator. In operator means we are checking if 2 is in the list 1. So it will return either true or false. In this case, 2 in list 1, yes, we have 2, so it will return true. Now 2.5 in list 1, no, all the values are whole numbers. There's no decimal number. So it is going to return false because there's no 2.5. We have 2 or 5. So in is we checking whether the item is in the list. If it is, we get true return. If it's not, we get false return. So sometimes we should know about the off by 1 error. With the, as we said earlier, with the list, the position is from 0 to 9, means up to 10. So if I write 0 to 10, that means I have 11 items now. So that is the concept of off by 1. So if I have a counter starting from 0, and I say the counter I is less than or equal to len first, len will give you the number of items we have in the list. But the index is by 1. So if I have 10 items, len will give me 10. But when I start from 0 to 10, I'm going to get 11 items. So that's what we mean by off by 1 error. So a list comprehensions, again, provide a concise way to create item from sequence. So a sequence will be an object that consists of an items, list of items. It's in order. So a list comprehension consists of brackets containing an expression followed by 4 clause, then 0 or more of 4, or if clauses. Now, the result will be a list resulting from evaluating the expression. So let's see the example here, which again will make us understand the concept list comprehension. So for example, we have list 1. Here we say list 1 is equal to x, where for x range from 0 to 1. So this means, remember, when we use the range from 0 to 5, it means we are going from 0 to 4. So 0 to 5 here will return a list of 0, 1, 2, supposed to be 3 and 4. The range 0 to 5 will return, it will give us 0, 1, 2, 3, 4. So now, if we want to know the item in the list, we write list 1, it gives us 0, 1, 2, 3, 4. Because here we say the range x for x range from 0 to 5. So it will go 0, 1, 2, 3, 4. Now, let's say we're going to have list 2. This time we say list 2 should be 0.5 times x for x in list 1. Remember list 1, we have 0, 1, 2, 3, 4. So 0, 1, 2, 3, 4, we are multiply it by each element by 5. Because we say x for x in list 1, which is all the items in list 1. We are going to multiply by 0.5. So our answer will be 0 times 0.5 will give us 0.0. 0.5 times 1 will give me 0.5. 0.5 times 2 will give me 1.0. 0.5 times 3 will give me 1.5. And the last value, 0.5 times 4 will give me 2.0. Now the next one, we say x for x in list 2. If s is less than 1.5. So this means we are creating a new list. And the list will be all the items in the list 2 that are less than 1.5. And we're going to store those items in a list called list 3. So if this is list 2, then we get 0.0, 0.5, 1.0, that's it. Is 1.5 less than 1.5? No. Is 2.0 less than 1.5? No. So only the true conditions will be stored in list 3. So if we invoke list 3, it will give us the items there, which is 0.0, 0.5, 1.0. Now, next we're going to compare lists. So for example, we have list 1 and list 2. Now we are comparing if list 2 is equal to list 1. Of course, no. You can see the starting green, red. They are all in different positions, so no. If, for example, we have green, red, blue, and the next one also green, red, blue, then the two lists will be the same. The position of the characters or the words makes the difference. So it's false. Now the next question said, is list 2 not equal to list 1? Yeah, that's true. If they are not equal, then equality gives us false, so not equal gives us true. Next, we are comparing if list 2 is greater than or equal to list 1. Is list 2 greater than or equal to list 1? We say no. You can see the number of words in each. Now we say list 2 less than list 1, and that is true. And also list 2 less than or equal to list 1 is true, at least it's less. So that is true. So we can compare two lists using relational operators. Equal, not equal, greater, less than, or less than equal, or greater than equal. We have 6 of them. So next we're going to learn how to split a list. That's splitting a string to a list. So for example, we have welcome to the US. This is one sentence, so it's kind of like one string. All the 4 words are in one double location and double quotations. So we have the quotation, with welcome to the US. So this is like one string. Now, if we want to split it, then we use the method called split. So here, if we say welcome to the US dot split, it means we are going to split all the string into individual. So welcome will be one string, two will be another, there will be another, then US will be another. So we can see all the four words are separated. Now here we are splitting with empty space. So anytime we see empty space, we split. Now here we have another example here using the pound sign. All the values are together, there's no space. But anytime we see a pound sign, we are going to split it. Because in our split method, we are using the pound sign as an argument. So we can see here, we have 34 pound sign comes, so we split it, we get 13, another pound sign came. So we split it 74 separately. Oh, sorry, 78. After 78, there's a pound sign, so we separate. Then we print 45. Now we have seen a lot of theory. So let's see example of a code using lists here. So here we are going to have number of elements, which is 3. So here for simplicity, we are using 3 values in a list instead of 100. But again, the concept is the same. So we create an empty list called numbers with a square bracket. We have a sum, we initialize it to 0 to make sure there's nothing in the sum variable. We are using for loop to go through the element in the list. So here we say for I in range, the number of elements, in this case is 3. Then we ask user, so with the number of elements here, we can enter up to 3. So we ask the user now to enter a new number. We change the number to float, we put it in a value. Then what we do is that we append, which means we are adding the value or putting the value in the list name numbers. So we write numbers.append value. So we append the value to the numbers list. And each round we do that, we add the numbers together. So this will be 3 numbers. So at the end, we are going to add all the 3 numbers together. We join all the 3 values in a list and we add all together. So now to find the average, it will be the sum divided by the number of elements we have, which is the 3. Then we have a counter variable. We want to use this variable to monitor the number of elements which is above the average. We already found the average now. So what we need to do is to compare if the numbers in I will start from 0 to 2 because we have 3 values. So if the first I is greater than average, we increment the counter. Then we check for the second value greater than average, we increment 3 times, we increment. Then we get how many the count, we print the count. That will tell us the number of elements above the average. Then also we print the average value. So here we are using a list. Our list name is numbers. Again, for simplicity, as we said here, we are using only 3. The size is only 3. If size is only 3, I mean, it's not too difficult to write, or it will not take too long to write 3 variables or declare 3 variables. So let's see the animation. So first, when we start the program said the number of elements is 3. That's what we did. Then next, an empty list is created, and the list name is numbers, which is the second line. On the third line also, we have a variable sum is initialized to 0. Make sure there's nothing, because that's where we're going to put our sum. Next, we go through the for loop. We say for I in range 3. Number of elements is 3, so 3. This will allow us to enter an input. So here, for example, I'm going to enter 45. Click OK. So I enter 45. Then next, we are going to append the 45 to numbers. Numbers is our array, so 45 will be the first element in the array. Then we add it to the sum. The sum is 0, so our first sum will be 0 plus 45, which is 45. Then we go back. We are still in the loop. This time we have 2 now. The second value, let's say I enter 21 or 23. So we have a new value, 23. Then we find a sum. So we had a 23 to 45, that gives us 68. Then we go back again, the last value, because we have 3, a number of elements is 3, so it will go 0, 1, 2. And to access to enter any value, I enter 2, click OK. And it gives us the 2. So now we finish. We have 3 items. And next, we cannot run the for loop no more. Here they say what will be the average after the statement is executed. The average will be the sum value we get divided by 3. So in this case, the sum value was 70. And here we are dividing integer with integer. So if it's 70 divided by 3, that will give us 23. Let's try 23. Yeah, so that's wrong. Let's see, the average will be 23.33. I didn't include the decimal side, so 23.33. So now we count with the count start from 0, and we go through the for loop again 3 times. Number of element is 3, and we are going to compare each value. So first we compare, is 23.33 greater than the average? The average is 23.33. And our first value was 45, so that is true. So we have 1. Now second is 23 greater than 23.33, no. Then the last is 2, and that is true. So the program is finished, and it print the 2 output for us, the average and also the count, which is 2. So also we can copy lists from one to the next. So for example, here we have 2 lists, list 1, list 2. After this assignment statement, we assign list 1 to list 2. What happened? List 2 will point to list 1 section. So often in a program, you need to duplicate a list or a part of a list. In such cases, you could attempt to use the assignment operator as follows. Now, passing lists to a functions. Here we have a function named print list, and the argument is the list name. And we say for elements in list, we should print the elements. So this function will allow us to print all the elements in the list. So if the list have 3, 1, 2, 6, 4, 2, then print list, it will print all the values for us. Now remember here we say print list. We can also use the concept of passing by value. List is passed by value. So Python uses pass by value to pass argument to a function. And there are important differences between passing by the values of variable or the strings of passing list. Normally we have pass by reference, which means you are using the variable address. Pass by value means you are using the content, the value of the variable. We can have immutable objects, which means it doesn't change, or changeable objects, which means it changes. So let's start with the pass by value immutable object. So here we say for an argument of a number or a string, the original value of the number and string outside the function is not changed. because again, the numbers and the strings are immutable. They cannot be changed in Python. Now, in the changeable concept, for an argument of a list, again, the value of the argument is a reference to a list. This reference value is passed to the function. So semantically, it can be best described as passed by sharing. That is, the list in the function is the same as the list being passed. So if you change the list in the function, you will see also the changes outside the function. So this is a simple example. We have a main method, def main. We have x, which represents the int value. Y is a list. We have 1, 2, 3. Now we say m, x and y. So this will invoke the function with argument x and y, and the function name is m. Then after that, we print x, and also we print y first item. Now in the definition of the user-defined function m, we have the number, we assign 1001 to it, and we say numbers, the first 0 is 5555. We assign new number. So here also we can have a function name add. It takes two arguments, x and the list. Now we say that if not x in the list, then we are going to append the x to the list. Then we return the new list. And here we add 1 to the list 1. We print list 1. We add 2 to list 2. We print list 2. Then we add 3. And 11, 12, 13, 14 as a array. Then we print it. Then add 4 to list 4. Then we print the list 4. So here the output, let's go through the output. If I have had 3, 11, 12, 13, and 14, the output here will give me 1, because the difference is 11, 12, 13, 14. Now, if we have print list 3, list 3 is 11, 12, 13, 14, so it will print 11, 12, 13, 14. Then add list 4. If it's 1, 2, 4, then it will come. Then we print it. Now, next is returning a list from a function. So here we have a function named reverse, and the argument is a list. Again, we declare an empty list, and we say for element in a list, we are going to insert element in a 0 position. Then we return the result. So we have result.insert 0 and then the element. So here if we have list 1, 1, 2, 3, 4, 5, 6, and list 2 of reverse list 1, which means it will be 6, 5, 4, 2, 3, 1. We call the reverse method to reverse list 1 and assign to list 2. Here we should know that the list already has been reverse method, which is list.reverse. So list 2 will be 6, 5, 4, 3, 2, 1. Now, this is one of the common functions that we use list for, to search an item. So we have two types of searching method. One is the linear search, the other is again binary search. A linear search means if we have a list of items, let's say from 0 to 99, we're going to have our search key and we compare with the first item all the way to the end. So that's why it's called linear or sequential search. So here we say linear search approach compares the key elements, which is key, sequentially with each element in the list from beginning to the end. Now the method continues to do so until the key matches an element in the list. Or if it doesn't match, then it will reach the end of the list. So let's see how this works. We have a linear search animation here. So here they say we should enter a key as a number, then click next button to perform our search. You see that any value we enter, let's say here they enter 8. Yeah. Now when I click next, it's going to compare 8 with the first value. That's wrong. So move on to the second. We compare with 58. That's wrong. Then 66, 46, 33. We can't go no more. Again, which means the search item 8 is not in the list. Now, if we change the value to 66, let's see if we can change it. So we leave the size as 5. And here, unfortunately, we can't change the search key. We can change only the size. Let's see if we make the size 9. If 9 will come. Okay, so 9 came. So now we're going to use 56. No, let's use 67. Along the way, we want to see how it stops. So we compare 67 with the first item, it's not. Second, no. Third, no. Fourth, no. Fifth, no. Sixth, no. Seventh, we have a check mark, which means we have found what we are looking for. So the test, if 67 equal to 67, a key is found with the index number is 6, from 0 to 6, which is the 7th item. I'll click OK. So let's continue. So that's the concept. Now we saw it, linear search animation here. Our search key is 3. We compare 3 with 6, no. 3 with 4, no. 3 with 1, no. 3 with 3, 9, no. 3 and 7, no. 3 and 3, okay, we found what we are looking for, so we stop. And this is how again, since we are searching the item from the beginning to the end of the list, we can simply use the for loop. So this is our linear search Python code. It takes the name of the list, which we call LST, and also the item we are looking for, we call it key. So now we are using for loop. We say for I in range 0 to length list. So if the list size, you have to go up to the size is 10, then it will go 0 to 9. Remember for loop. So now we check if key equal to the list, then we return I. So when this condition is true, we are going to return I to the method, then we come out of the for loop. If we go through all the item and we reach the end of the for loop and we couldn't find it, then the final we are going to return again. -1 means the item is not in the list. So this is a very straight algorithm for linear search. Compare the first item to the search key all the way to the end. So a for loop is very good to go through all the items in the list. As we said, we can also use the binary search. Linear search is very good for small lists because imagine if I have a list, the size is 500 and the item is not available. That means I have to search all the 500 or the item is last. But when I have a binary search tree, it's good for the bigger data because first with binary search, we have to make sure that the item in the list are sorted in increasing order. So what we do is that we find the middle item of the list. We compare the middle item with the search key. Now, if it matches, then we finish. We only do one comparison. If it's not, but the middle item is greater than the search key, this means our search key is less. So we go to the lesser side. So that means half of the array, the greater part from the middle, we are not going to look there no more. So we go to the left side. Then we continue the process. We find the middle value, we compare with the search key. If we match, we finish. If it doesn't match and it's less, then that means we go to the lesser side again. If it's greater than the search key, we go to the greatest. If the middle value is greater than the search key, then we go to the lesser side. If the other way, we go to the higher side. Then the same thing we divide into half. So by the end, we will see that again, binary search may search only half of the items at least. Sometimes even way lesser than half. So here we say for binary search to work, the element in the list already must be in order. So it have to be sorted. Because without that, we get the middle value, we compare. If it's greater, we go greater. So if it's less, if it's not sorted, then we can't do that. So we can see the list of the items here again are sorted. So consider the following three cases. As we said earlier, if the key is less than the middle element, then you only need to search the key in the first half. You go to the lower side, the items that are lower than the middle. If the key is equal to the middle, then return the search key. That means the middle is the core. Otherwise, if the key is greater than the middle, then we go to the greater part, the right side, after the middle. So this is the annulation. We have a list of items. We are looking for 8. So first thing, we identify the middle. The middle is 4. So when we compare 4 with 8, we find out that 8 is greater. So what happened? We go to the right side. The right side, we have 4 elements. We take the middle value is 7. So when we compare 7, we go to the next item, then it's right there, fine. So again, we can see the first items, we need to get the middle value. Compare the middle value. Oh, the middle value is lesser. So this means we have to go to the greater part, which is 6, 7, 8, 9. The middle value that we find was 7. Then when we compare 7, 7 stay less. So we need to go to more greater. This time only 2 left. So the middle value is 8. We compare 8 with 8. Okay, we finish, we match. So this is the animation also. Let's leave it as, well, let's increase it to somewhere 10. And search key can be any value. Let's use 2. Okay, so first we are using 2. Compare 2 is lesser. So we go to the left side. Still it's not there, so we finish. Now let's reset it and make the, okay, now we are getting the 10. We can make the search key to be somewhere, let's use 76. So see what happened. We get the middle value to be 52. Since 76 is greater than 52, so we go to the right side. At the right side, our middle value is 76. So when we compare, it matches 76, 76. So that's the concept here again. We have the key to be 11. So we are looking through this list of items if there's 11. So first, we need to know the middle value. So the middle value was 50. Since the key is less than 50, we go to the left side, so the half is gone. So these are the remaining. And now we look for the middle. The middle was 7. We compare 7 with the key, no, is greater, 11 is greater than 7. So we go to the right, only 10, 11, 45 left. We take the middle value. The middle value was 11. We compare 11 with the key is 11. Okay, we find it. The position is index number 4. Again, when we are searching something, we want to know the location of the thing. So we're always going to return the index. And the same example we have here. The key is 54. So first thing we divide into half. We look at the middle value at index 6 is 50. No, 50 is less than 54. So we go to the right side. Then we get the middle value. The middle value was 66. But 66 is too big, is greater than 54. So we go to the left side. The left side, only two items left, 59 and 60. So let's say the middle is 7. We compare, and 7 is less than 59. And the right, so this means we didn't find the item. So again, binary search is a very good concept. If you have it's a very good choice if you have a large items, because every run you are going to remove half of it away. But with linear search, you have to search from beginning all the way to the end. So this is the coding in Python. We start with the low variable here represent the beginning of the index, which is low. High will be the end of the index. Remember, if the size is 10, then it will be 0 to 9. So that's why we say length least minus 1. Then first, this will make sure the items are sorted. Why high is greater than or equal to low, which means the item in the list has been sorted. We find the middle value by adding the low plus high divided by 2. That's the low index and higher index. So if the higher index is 9, or let's say 10, 0 plus 10 is 10 divided by 2 is 5. So our middle value will be index 5. Then we compare it, the middle value with the key. So we say key less than, if this is true, then we go the higher lower section, because in this case, the middle value is greater than the key, or the key is less than. So we go to the lower section. Other than that, we go to the higher section, which is here. Then we go through, this is a while, so we go through all the list. So anytime we find it, then we return either the index, middle or middle plus 1 or middle minus 1, whatever the middle is. So because in binary search, we also do sorting, we want to go through some few sorting in the sorting concept. So sorting like searching also, we can use it a lot in lists, and also it's used in many programming tasks. So we say many different algorithms have been developed for sorting, but this session will introduce only two simple ones, actually the selection sort alone. If you take a data structure class and algorithm class, again, there are more than somewhere between 5 to 10 different sorting algorithms. So selection sort algorithm said that if you have an item, look for the lowest item and bring it to the middle. So just by looking at this diagram, we went through the list and we found out that 1 is the lowest item. So we swap it with the first item. Then we go through the list again. 2 is the lowest item, then we swipe. The one we swipe, we don't count it no more. Then we go through the list again. We start 4 is the lowest, we swipe. Then by swiping to the middle, you see that at the right side, we also have to go. So now the rest is 8, 9, 6. 6 is the lowest, we swipe with 8. Now we have 9, 8. 8 is lowest, so we swipe with 9. So at the end, we have it. So the algorithm said, selection sort find the largest number in the list and places it at last. Then it finds the largest number remaining and places it next to last, and so on until the list is again fully sorted. So we also have the animation here. So we want to sort this list of items. So we click next. The lowest value was 25. So we exchange. So now we're going to sort from 66 to 95. The lowest will be 66, so it will be in the same position. Then now we go through the list, 91, 79, 95. The lowest was 79, so we swap. Then next we go through the list, 91, 95. They are in the right position, so we stop. That's that's it. So that's the concept here again. To repeat, we have a list of items. So for I in a range, that's the how many items we have in the list. First, we select the smallest element in the list and we swipe it with the first item. And we keep doing this to the second, third until all the items are again sorted. So that's the algorithm. Now we have the Python code, which is right here. Again, we shall go through them here for I in range. So again, the for loop, we start from 0. If the size is 10, we go from 0 to 9. So 0 to the len list. Select the smallest element in the list, then we swap it with the largest item. Then we do the same thing to the next values until we finish. So again, that's the final code in Python language. So for I in the range if it's 10, the list, then we get 10, but we want to go up to 9. So 10 minus 1. Find the minimum in the list. So we use the main function and go through the list, get the minimum value. Then we say the next counter plus index. Then we swap it. And we go through the list until invoke it. It's a for loop until we reach the end of it. So that will be the conclusion of our lectures in list. And the most important concept here is at least we should understand what is a list, how do we create a list, and also the syntax of a list. And the methods, again, a list is a class. So we need to consider the methods that we can use on the list. For example, reversing a list, removing an item, popping. Removing means we remove the first occurrence of the item. Pop means we have to specify the position. So we're going to remove a particular item in a particular position, etc. So again, wish everybody the best and see you in the next lecture.